Hi there. Today our topic is a very interesting one. It's called the gravitational forces. I think you all have a pretty good idea on what is gravity. For the first picture here, this is what you have when you try to throw a cat out of the plane. And I think you know what will happen next. And also in the rainfall, gravity is the one that is responsible for pulling all the water down. And also this is the one that causes all the flooding. And then if you look at the third picture here, so over here we have our solar system. In solar system we have our sun here that's exerting gravity and pull all the planets to revolve around it. So all these are effects of gravity, and we located in the earth here is also moving around the sun due to the gravity. This is the content of today's video. First of all, I'm going to define the gravity, give you a proper definition, and then I'm going to proceed by giving you the formula of gravity as well as discussing its intrinsic property. Before I begin, let me remind you gravity is extremely important. It is everywhere and you cannot shut it down. It is the reason why you're being very careful whenever you're using the staircase. If you're not careful, things are not going to be nice later on. Okay, so a little bit of history. So this is a gentleman who introduced the notion of gravitational force to Earth. The same gentleman who saw the movement of an apple and then the movement of the moon, as well as inventing the reflecting telescope. We are still using reflecting telescope nowadays. Same gentleman also was the one who split the white light into the rainbow colors, as well as inventing calculus, that you might love it or hate it very much. I'll start by introducing the formula to you, just in case you do not know the gentleman just now. Perhaps now you have a better idea. We generally regard this formula as the law of universal gravitation. So this is F subscript G equals to capital G, capital M, small m over r squared. So F here is the gravitational force, and both capital M and the small m here are referring to the masses of two bodies, of course in SI unit, kilogram. Then the r here is the distance between the centers of the two bodies. Alright, so it's the distance between the centers, and then r here is not referring to the radius. Please remind yourself about that. And the capital G here, this is a new number. It is called the gravitational constant. It is a constant and it has a very small value. So what's the value? I will let you investigate the value by doing all the activities, and I hope that you can get it. With the formula given, now I'm going to proceed by telling you the definition of gravitational force. Gravitational force here is a force of attraction, purely attraction, and is acting between two bodies. Okay, two bodies, and the small m, capital M here are referring to the mass value of both objects. For example, what do we have here? Let's say we have a tennis ball, and let's say the mass is small m, and we have another one recycle bin with a capital M here representing its mass. So what will happen? If you're going to put it, let's say side by side, you will expect that there is a gravitational force that is acting on both of them. There is a force of attraction between these two objects. Yeah, but the thing is that you might not realize it because it's extremely difficult to detect it. With the same example, let me describe further about the nature of the attractive force. So with this example, on the left hand side here, I do have a red color arrow here to represent the gravitational force on the tennis ball. This red color arrow is attraction due to the recycle bin. Yeah, so it's an attraction force due to the recycle bin. And similarly, the red color arrow on the right hand side on the recycle bin is actually an attraction due to the tennis ball. So what it's saying over here is that gravitational force is not only an attractive force, it is acting equally with the same magnitude and oppositely on each mass. Is satisfying the Newton's third law. F1 equals to negative F2, So negative here to represent one of the force, the direction wise is opposite to the other. By knowing the nature of the direction of force, now what we need to concentrate, we need to know the strength of the force. We need to know the magnitude of the gravitational force that is acting between the two bodies. So one thing that we need to know is that this force depends directly on the mass of each body involved. So if I'm going to change an object, let's say I have the two sphere here, one is a small m, another one with a capital M. And we know, first of all, the force of gravity is acting on both them with the same magnitude with different direction. So if I'm saying that the mass is important in determining the strength, now if I want to ask you a question, what happened to the force if now I'm going to double the mass of this capital M? Namely, this M here, I'm going to double it. What happened to the new force according to this relationship? And let you think a bit. I'll review the answer. The force is going to be double, right? It's now it's no longer Fg, it's 2Fg, simply because you double the mass. If I want to ask you one more question, now, how about I double the mass of both objects? Right, both objects, I double the mass. So let's say the M, I already double right now, is times 2. Now the small body also, I'm going to times 2. What is the new force for such case? Yeah, I give you some, right, 3 seconds, think about it. 1, 2, 3, 4. Yeah, so if you can get the answer shall be 4Fg. It's 4 times because you double here, you double. What happened is that 2 times 2 is 4 times the original force. After considering the mass of both objects, now when we look at the equation, there is one more parameter that we need to emphasize, which is the r squared. As I mentioned previously, r here is referring to the distance between the center of two objects. R here is not referring to the radius, okay, so you have to remind yourself. So as you can see, the force here is varying according to 1 over r squared. This is what we call as the inverse square law. So what happened here is that if you're going to make the r bigger, the force here will become smaller. So over here we have a picture. Let's say I give you this scenario, both objects with small m and capital M, with the distance them between is given by r. Now I'm going to ask you a question. What will happen if I'm going to double the distance of r? What is the new value of the force here? Okay, I give you some time to think about it. Alright, now with the same question, if I'm going to double the distance between the two objects, now it's no longer r, it has become 2r. What will be the new value of the force? Okay, so this is the answer. The answer shall be the force here divided by 4. Okay, it is same for both objects because it's an action-reaction pair. And why is it over 4? Is because if you double the distance, the strength decreases by 1 over 2 square. 1 over 2 square is 1 over 4. That's why the force here becomes weaker by a factor of 4. Alright, now a quick summary to the key points. Number 1 here is that gravity is always a force of attraction, never a repulsion, remember that. And also it forms a pair of action-reaction forces, just like the Newton's third law. And then what happened is that the strength of gravity depends on the mass of each body. And the number 3 here is the strength also follow the inverse square law. So what is inverse square law? It means that the force here that we have is getting weaker by the factor of r square. And then we do remember the m here referring to the mass. The greater the m here, the greater the force. So this is the relationship. And how do we turn a relationship into an equation? This is how we are going to do it. We put an equal, and then we have to put an unknown here, a constant. G here, the capital G, is the gravitational constant that we can find it out by using experiment. And this is the full equation, universal law of gravitation. I will let you to do the activity to find out what is this value of capital G. It is a very small value, and please do the activities and find out the value. Thank you.